Good evening everyone. This is Sangeeta, Assistant Professor, ECE Department, SNS College of Technology, Coimbatore. So in this video we are going to cover Wien Bridge Oscillator. So let us have a small recap about the previous session. So in the previous session we studied about RC oscillators and its types, and there are two types of RC oscillators, RC phase shift oscillator and Wien Bridge oscillator. So in RC oscillators it is mainly used to produce oscillations in the audio frequency range, and in RC phase shift oscillator there are three RC networks, and each RC network produces 60 degree and the amplifier produces 180 degree, so totally 360 degree. So let us move on to the Wien Bridge oscillator. So Wien Bridge oscillator, why we need Wien Bridge oscillator? So the main purpose of Wien Bridge oscillator is to overcome the RC, the disadvantage of RC phase shift oscillator. So what are the disadvantages? So in RC phase shift oscillator, the starting the oscillations is very difficult because it has a very small feedback network and the output produced is very small. So these are the main disadvantage of RC phase shift, and it is overcome in the Wien Bridge oscillator. And another main reason for using Wien Bridge oscillator is the frequency can be varied in the Wien Bridge oscillator. It can be varied from 10 Hz to 1 megahertz. So this is the one of the main reason. So next we will see the circuit diagram. So this circuit is free from the circuit fluctuations and the ambient temperature. Here there is a Wien bridge, that is R3, R1, C1 are connected in series of the one arm of the Wien bridge, and R2 and C2 is connected in parallel in the one arm of the Wien Bridge oscillator, and in the last arm LP, that is tungsten lamp, is connected. So the here I have to say what is the use of tungsten lamp. The tungsten lamp is mainly used to produce automatic gain control. So, due to the automatic gain control, the frequency stability can be increased. And here there are two transistors used, T1 and T2. So, and one coupling capacitor is used to couple the first transistor to the next transistor, and the bias resistor and collector resistor are used, and there are two coupling capacitors, and in T2 also there is a coupling transistor. So the main working of a Wien Bridge oscillator is when the switch is on, the Wien Bridge network produces oscillation, and it is given to the T1 transistor. It acts as an amplifier plus oscillator. So here it is amplified, and it also produces 180 degree waveform, and the Wien Bridge oscillator produces 180 degree waveform, and the oscillator, that is T1, it acts as an amplifier also. It also produces 180 degree phase shift. So totally 360 degree phase shift oscillations. So here the Barkhausen criteria satisfied, and the transistor T2 acts as an inverter. So the produced, why we are using here the inverter is, so here this circuit will explain well. So in the bridge oscillator, there is an oscillation produced, and in the amplifier it is amplified, and it is the output of the amplifier one, that is the output of the T1 is 180 degree phase shift, and the T2, that is the second transistor, act as an inverter. So the phase shift is inverted here. So we can get the oscillation at 360 degree. So this is the operation of Wien Bridge Oscillator. So the main advantage of oscillator, Wien Bridge Oscillator, is the circuit provides good frequency stability, and also it provides constant output. The operation of the circuit is very easy, and the overall gain is improved because of here we are using two transistor, and also additionally we are using tungsten lamp for automatic gain control. So the frequency of the oscillation can be changed easily. This is one of the main advantage of Wien Bridge Oscillator. So there are some disadvantages. The circuit cannot generate very high frequencies because it is used to produce from 10 Hz to 1 megahertz, and two transistor and number of components are high. So these are the advantages and disadvantages of Wien Bridge Oscillator. And these are the assessment questions. The first question is, a Wien Bridge Oscillator is based on the principle of dash bridge network, that is a Wien Bridge network, and the Wien Bridge Oscillator is widely used as a dash frequency sine wave generator, and the oscillator requires an amplifier with a gain of at least dash gain to sustain oscillation. The Wien Bridge Oscillator produces a phase shift of dash degrees, and in practical circuits, dash devices such as lamps, diodes are often used for automatic gain control. So these are the answers. The Wheatstone bridge, and for the second question it is audio frequency sine wave generator, and the third one is 3, and the fourth one is 0 degree or 360 degree, and the answer for the fifth is non-linear, that is thermistor and lamp or diodes. Here in Wien Bridge Oscillator we are using tungsten lamp. So hope this video will help you to understand what how the Wien Bridge works and what are the advantages and disadvantages. Thank you.